Once again, good morning, everyone. I would invite Deepashri ma'am to start the session. Deepashri ma'am,
So am I audible?
yes, ma'am, you're audible.
Okay. So yesterday we started with the chemical bonding and we did only the ionic bonding part, right? So what is chemical bonding? It is actually the bond which is used to hold the molecules together. So far in the periodic table, we have learned about the chemicals, but about the elements. But now in this chapter, we will be learning how the molecules like why are the molecules, like how the elements join to form the molecules. Okay, so these are the different things we have seen, and this was the most important chart. I told you that read those chart, and before writing any formula we will first see which gains and which loses electron. Like someone has to gain, someone has to lose. Both elements losing or both elements gaining, this will not result in the formation of any kind of compound. Okay, so first we will see which loses, which gains. This is an ultimate property to start with the formation of a molecule. And then we saw different elements, different examples, and we did till here. We drew the Lewis structures, and we know that the Lewis structure has only kinds of uh, elements drawn with only the valence electrons, right? Now, metals. So the metals lose the metals, they actually lose the valence electrons and they achieve a stable valence shell, and they also gain a positive charge, that is the positive ion. So metals will be losing valence electron, non-metals will be gaining the valence electron. So this is what we have learned so far up to this chart. And we also know how to write the formulas, right? So how to write a chemical formula for an ionic compound. This is something we have learned. So today we will be starting with what are the, so till yesterday, anyone has any doubt? Anyone, any doubt? No. Okay, so what are the conditions for the formation of the ionic bond? So ionization energy of the electropositive atom should be low, and electron affinity of the electronegative atom should be high. Lattice energy of the ion crystal should be high. Now, what is the ionization energy? Who will tell me what is the ionization energy and what is the electron affinity? These two concepts we have learned already in periodic table. So someone just unmute yourself and say what is the ionic energy and what is the electron enthalpy. Say.
Which is ready to remove an electron.
Yeah, what is this? Ionization energy is the energy which is required to remove an electron from a valence electron only for gaseous atom. And electron enthalpy is enthalpy associated with addition of an electron to an isolated gaseous atom in the ground state. So there are two differences. One is the addition and one other is the uh, removal of the electron. So these are the two different concepts. So ionization energy will actually, yeah, good. So the ionization energy for the electropositive atom should be low, and electron affinity for the electronegative atom What are the electropositive atoms? Sodium, potassium, anything you see in the left-hand side of the periodic table, okay? Those are the electropositive. Electronegative are fluorine, chlorine, bromine, iodine, oxygen. Those are the electronegative ions. So electron affinity, that is the tendency to gain an electron. For the electronegative atom should be high and ionization energy that should be low. Only in this condition that ionic bonding will be formed. Is this part clear to everyone so far? So now,
Yes, ma'am.
okay, just wait for. Yeah. So what is the variable valency? Heavier p block elements with high atomic number, transition and inner transition elements exhibit more than one valency. And this is referred to as the variable valency. So can anyone tell me what is the transition and what are the inner transition elements we have learned in the periodic table? This is just a recapitulation. What is the transition and what are the inner transition element? Transition and inner transition element. Can anyone tell me what are the transition and what are the inner transition elements? No one. So the transition elements actually are the group of the elements in the periodic table that occupies the D block. And they are located in between S block and the P block elements. Whereas the inner transition elements, these are the group of elements that occupy the F block. And F block have lanthanides and the actinides. Always remember, transition elements are D block elements, inner transition elements are F block elements. Okay, so F block element is only the inner transition. D block element is the transition. So the transition elements have partially filled d orbital, different kinds of oxidation states, colored compounds, and so on. Okay, so this is the thing. Just wait for 1 second. I have a problem in presenting the slide. So that is the variable valency. Like iron exhibits an electrovalency of 2 and 3. Tin exhibits valency of 2 and 4. And these elements are referred to as the different valencies in the younger classes, like in class 8, class 9, you know about valencies. Iron has 2 valency, tin has 2 valency. These are said to have possess variable valency. So variable electrovalency is actually due to unstable electronic configuration of iron and the inert pair effect. So what is this? Inert pair have some of the heavier representative of elements of 3, 4, 5. Remember, these elements of the groups 3, 4, and 5, they are the representative elements and they are said to have an inert pair effect. Inert pair effect causes the unstable electronic configuration. Unstable electronic configuration actually results in this different valencies of a single element. So they have an outer electronic configuration of ns2np1, ns2np2, ns2np3. So they can show valences with a difference of 2, like 1 3, 2 4, 3 5. See, there is a difference of 2. So 1 3, 2 4, 3 5. So these are the different valences. So is this part clear or should I explain again? So does anyone have any idea what is an inert pair effect? Anyone, do you know what is the inert pair effect? So inert pair effect is actually the phenomena which is observed only in, I will say, group 13, 14, 15. See, group 3, 4, 5, that is the older group. You can write here as group 13, 14, 15 according to, and sometimes 16 also in the modern periodic table. Okay, so it is the tendency of the two electrons of the outermost s orbital, okay, to remain unshared. Like, see, two electrons in the outermost s orbital, two s electrons in the, they will remain inert, means they will neither be lost nor there will be any gaining. So that means they are inert, so they don't participate in the formation of bond. This is referred to as the inert pair effect. So inert pair effect causes the unstable electronic configuration. Unstable electronic configuration ultimately results in the variable electrovalency. So ultimately valences will be like 1, 3, 2, 4, 3, 5, and so on. Okay. So see, in ionic bond, some covalent characters is introduced because of the tendency of the cation to polarize the anion. In fact, cation attracts the electron cloud of the anion and pulls the electron density between the two nuclei. You know what is a cation and what is an anion? Now someone explain me, why is this cation I have drawn smaller and this anion I have drawn larger? Do you know? Yes, you should know. I've told you in the periodic table that if there is a cation, then there is a loss of electron. Loss of electron and number of electrons and number of protons are same. One electron is lost, but the proton number remains constant. So force of attraction increases. So there is a squeezing, and that is why the shape of the ion reduces, and that is size of the ion reduces. So that is why cation is smaller in size, and for anion means negative. Negative means gain of an electron. Gain of an electron means that there is an extra electron now, but number of protons remain constant, so there is no extra additional attraction. That is the reason what happens, there is no attraction, no additional attraction, and that is the reason rather than repulsion is created, because the other electrons will repulse it, so the size increases. So anion is larger in size than the cation. Now, you know about the cations and the anions. So what does this statement mean, that in ionic bond some covalent character is introduced because of the tendency of the cation to polarize the anion? In fact, cation attracts the electron cloud of the anion and pulls the electron density between two nuclei. So what does this mean? What is actually it is being asked? See, that I am saying that even in the ionic bonds, there is a tendency for the cation to polarize, means introducing some kind of the covalent character. So can you think that, so it is not correct to say if we say that ionic bonds solely introduce ionic characters. No. Ionic bond sometimes introduces the covalent character. So, what are ionic bonds? Ionic bonds are formed when one atom donates electron, another atom accepts electron. So, thus ions are created of opposite charges because someone is losing, someone is gain. So ultimately two opposite charges ions are produced. So there is an electrostatic attraction between them, and this results in the birth of a ionic bond. Okay, so this is something, the birth of an ionic bond. Now covalent bonds are formed when two atoms are of same nature. Okay, and both share electrons. Okay, so when ionic bonds are primarily based on electron transfer, there is a slight nuisance, like the cation's positive charge can influence the electron cloud of the anion. It is shown by the experiments. Okay, so the cation's positive charge can attract the electron cloud of the anion towards itself, and this distortion, so there, so this attraction creates a distortion of the electron cloud. This distortion of the electron cloud is called the polarization. And as the electrons cloud is now pulled towards the cation, there is a greater overlap between their electron clouds. So more the overlap, more electron sharing. So electron sharing is a characteristics of covalent bond. So ionic bond sometimes introduces covalent characteristics. Okay, so there are different factors that affects the covalent bond, which we will learn in the covalent bond. So this was proposed by scientist Fajan, and this entire phenomenon is called the Fajan's rule. So is this part clear, that ionic bond will create some kind of the covalent characteristics? How they will create? Cation's positive charge will attract the electron cloud of the anion towards itself. This results in the distortion of the electron cloud of the anion. This distortion of the electron cloud is called the polarization. And as the anion's electron cloud is pulled towards the cation, there is an overlap between their electron clouds. More overlap means more sharing of electron. And sharing of electron, this phrase is particularly used to describe characteristics of covalent bond. So ionic bond can also result in the creation of covalent bond. Is the last slide clear to everyone? How
Yes.
yeah. So how the ionic bond is introducing some amount of covalent character. So what was the basic conclusion for the Fajan's rule? According to Fajan's rule, magnitude of covalent character in the ionic bond depends upon the extent of polarization caused by the cation. In general, smaller size of cation, larger is its polarizing power. Larger anion, more will be its polarizability. More charge on cation and anion, presence of a non-polar solvent, cation with an electronic configuration other than noble gas. So, how much covalent character is being introduced by the ionic bond? This will depend on different characteristics. And what are these different characteristics? These are the different characteristics. Cation size should be smaller. More smaller size of the cation, more will be its polarizing ability. Polarizing ability means its ability to attract the electron cloud of the anion towards itself. And what is the polarizability? Polarizability is the fact that the ability of the anion to be attracted to the positively charged cation. Okay, so smaller will be the size of cation, larger will be the size of anion. Most important point. So more charge on cation and anion, obviously, because I am saying smaller the size of cation. Suppose there are two cations, M plus, M2 plus. M2 plus means more smaller in size, because M2 plus means that element has gained 2 electrons. So 2 electrons means, but the number of protons remains constant, but there is an excess of 2 electrons. So more will be the force of attraction, more squeezing. So more reduced will be the size of the cation. Okay, so M2 plus is smaller in size than M plus. Is this part clear? What I told you just now? So smaller but see, charge is higher. M2 plus charge is higher, but the size is smaller. So obviously, if you remember this statement, obviously this statement becomes correct. More charge on cation means smaller the size of cation, larger the size of the anion. Is this part clear? And this entire phenomena can only happen like the ionic bond can create an non-covalent can create a covalent bond, only covalent characteristics only in the presence of a non-polar solvent. Okay, and cations with electronic configuration other than noble gases, obviously. So is this part clear to everyone?
Yes, ma'am.
Okay, good. So what is the covalent bond? Covalent bond means previously in the ionic bond, one of the element was losing electron completely, another element was gaining that electron completely. It was more like someone is donating something and the other one is just accepting it. Like you, it is a birthday and you are giving a gift to your friend. Whatever you have given, it is gone and someone has gained, right? That is the ionic bond. Okay. Now, what is the covalent bond? Covalent bond is like starting a business. Two friends again. Someone is saying, I will contribute this. Your friend is saying, I will contribute this. No one is like donating, right? It is not like you are investing here. So it is not gone. So can you realize this minute difference? Your thing is not gone. Is it gone? Like if you are investing something, is it gone? No, you are expecting something in return. You are expecting by sharing stuffs, I will be benefited. Instead of business, forget about business. Just think that you are sharing something with someone. So is it gone? No, sharing means you are not totally giving it. It means you still have the possession for that particular thing. You have shared your pencil with your friend. Does this mean that that pencil is gone forever? No, you are sharing for a particular period of time, right? Again, you can have that back. So covalent bonding is something sharing. Remember the term sharing. But if you are gifting a pencil to your friend, it is gone. Bye bye, tata, gone. That pencil is gone from you forever. Okay, but covalent bond means sharing. I am sharing this with you. You need this, I am sharing. Okay, and even by sharing, people will see that okay, you are sharing someone, you are a good human, so obviously you are benefited, and someone who needs that thing also is benefited. So this is the covalent bonding. So bonding between the non-metals. Again, bonding between non-metals. I told you in the periodic table where are non-metals present? In the P block, means in the extreme right hand side of the periodic table. So if you know what are the P block elements from the periodic table, you know what are non-metals. Now you see two non-metals. You will see, okay, two non-metals, both are of same nature. There is a high probability that these will be the covalent bonds. There will be the covalent bonding in between these elements. Is this part clear? How
Yes,
you will realize that where covalent bonding will be present, where ionic bonding will be present. All atoms included have fairly high electronegativity, few vacancies in valence energy levels, obviously. Consider chlorine. Chlorine has 7 electrons in its outermost shell. So it just needs one more electron. Right or wrong? Right? So when they bond, they gain electron to achieve the stable electronic configuration. Hence, electrons are shared. Very important point, shared. Sharing produces low energy, stable electronic configuration. See, helium is 2, neon is 2, 8. So 8 electrons. Argon is 288. So covalency is the number of electrons an atom needs to gain to produce a stable outer shell. Now, the number of the shared pairs, that is the covalent bonds of electron and atom forms hydrogen. So hydrogen needs one additional electron. Hydrogen bonds one pair. Wait, hydrogen bonds one pair of the electron shared between two atoms. Covalent bond, bonding pair of electron orbits both nuclei, attracts both, provides the bonding force. Hydrogen molecule consists of two covalently bonded hydrogen atoms which have no tendency to bond further. See, hydrogen, the chemical formula is H2. Right? And one hydrogen has one electron. You know, from the periodic table, hydrogen has atomic number 1, and even in its valence shell, it has one electron. Now, I told you in maximum cases, hydrogen will try to lose an electron. But sometimes hydrogen also tries to gain an electron. Okay. So in the process for formation for H2 molecule, hydrogen needs to have one electron, one additional electron. What does hydrogen do? Two hydrogens come. Okay. You and your friend. Okay. So you are telling I have one pencil. Your friend is telling I have one pencil. Now you need two pencils to do a particular task. You are sharing, let's make a bond. I will share my pencil. He is saying, I will be sharing my pencil too. So both of you are sharing two pencils, one from each. It is sharing. Okay, it is not like one of the hydrogen has gained both the pencils, both the electrons, and another hydrogen has 0. Now, maybe for the case of hydrogen, this can be good. Okay, for hydrogen, this can be good. Because if one of the hydrogen gains both the electron, it will become like helium, which is an inert gas, stable electronic configuration. Another hydrogen will become 0. And 0 is also stable electronic configuration. So this condition can exist. But for other molecules, this will not happen. If now we will be learning this in the next chapter. Often in friends, have you seen Doraemon? Here, anyone? Like, are you familiar with cartoons or anything like that?
Yes, ma'am.
Okay, good. So you know, right? So Jian is the character who always snatches everything. But Jian and Nobita both are friends. So there should be equal sharing. He is saying, I will share you something. Nobita is saying, I will share you something. But maximum cases, we see that Jian is snatching from him. So what happens if during covalent bond, one of the element is slightly more electronegative than the other? Like consider HCl. Okay. Chlorine is more electronegative than hydrogen. Okay, because chlorine is more of a non-metal. So hydrogen has one electron, chlorine needs one electron. Okay, so both are saying, okay, we will be sharing the electron. Okay, so hydrogen is saying, okay, I need one additional electron. Remember, here hydrogen will not lose the electron. Here hydrogen tries to gain electron. In covalent bonding, hydrogen will try to gain electron. In ionic bonding, hydrogen will try to lose electron. Okay, remember this. In covalent bonding, hydrogen will try to gain electrons. So here hydrogen and chlorine both has a tendency to gain electron. One more thing you can understand, that in ionic bonding, someone is losing, someone is gaining. In covalent bonding, both have the same interest, like both wants to gain. Okay, so here hydrogen wants one electron, chlorine also wants one electron. So hydrogen and chlorine will pair up and say, okay, chlorine will say, okay, hydrogen, I am using your one electron. Hydrogen will say, okay, chlorine, I am using your one electron. This is an ideal situation. But chlorine is like Jian. Chlorine is slightly more powerful than hydrogen. Why? Because chlorine is more electronegative than hydrogen. So chlorine, now you will ask me, ma'am, how will I know which is more electronegative? For that, you have to learn the periodic table thoroughly. Because in periodic table, there is written how to determine the electronegativity. Across the period, it increases, down the group, it decreases. So you know the position of hydrogen and chlorine in the periodic table, and accordingly, you will know that chlorine is more electronegative than hydrogen. Okay, so now see, chlorine is slightly more electronegative than hydrogen. So chlorine will now try to snatch the electron from hydrogen. So see, now you can think that covalent bonding gives us the concept for ionic bonding, because in ionic bonding, it was like a birthday gift. You were willing to give someone something. But here, it is sharing. But someone is trying to snatch it from you. Did you get the difference? What is the difference between covalent bonding and the ionic bonding? For now. And how to know which elements will have covalent bonding, which elements will have ionic bonding? Is this part clear to you now?
Yes, ma'am.
And how did we link the periodic table? Okay, see. So, okay, now you can say what is covalency? Covalency is fluorine. Consider fluorine. Fluorine is 9. Okay. Atomic number of fluorine is 9. So, 2, 7, K shell, L shell. And L shell can have maximum of 8 electrons. I told you that magic number concept. So, fluorine will need one more electron. So covalency of fluorine is 1. How many electrons any electronegative atom needs to fulfill its stable electronic configuration is referred to as the covalency. Is this part clear? Clear or not?
Clear, ma'am.
Good. So, this is something again. Important, this melting point and boiling points. These are very important for your Neet. Do not conduct electricity, soft. These properties are important for your boards, most of the cases. That does not mean that you will not be learning about them in the Neet. Because 1 mark, 4 mark question just for your sake of knowledge. That is a fact-based question can come in your Neet. So this table is very important. So this table shows properties of covalent molecular compounds and explanations of these properties. Do not conduct electricity, no mobile charged particles. Molecules are not charged. Electrons tightly bound to the atoms or shared by atoms in covalent bond. Melting boiling points, during melting or boiling, molecules become separated. Forces of attraction between molecules are weak and little thermal energy is required to separate them. Soft molecules weakly attract to each other and are easily dispatched. So these are the basic explanations and the basic properties. Okay, so see, this is something I was telling you. Suppose consider an example HCl. Okay, so chlorine. If you have done the periodic table, you can know that chlorine will need one more electron, okay, to fulfill its octet. And hydrogen, I told you in covalent bonding, hydrogen will try to gain electron. So hydrogen also needs one electron. Chlorine also needs 1 electron, but chlorine, fluorine, these all things, these all are more electronegative than hydrogen. Now, how to know if an element is more electronegative? So go back to periodic table and see the trend. Then you know this is placed here in the periodic table, this is placed here in the periodic table. Just compare and you will know that, okay, so this element is more electronegative than hydrogen. So more electronegative means they are like Gr. So they will try to snatch the electron. And snatching means respect is gone. So trying to snatch means they have not yet snatched. They are trying to snatch. They are on the process of snatching. After this covalent bonding, I will be starting the GOC or your organic basic parts, because these are the concepts I will be needing in the first parts of your organic. Okay. So carbon is like, okay, I need those electron. I will try to snatch away those electron. Thus chlorine has completely taken away that electron from hydrogen, or is it trying to snatch? Unmute yourself and say. Say. It is trying to snatch. It is not like chlorine has totally taken away the electron from hydrogen. If chlorine has totally taken away the electron from hydrogen, that will be an ionic bonding. And there, chlorine will have a pure negative charge. But in covalent bonding, chlorine is trying to snatch electrons from hydrogen. So chlorine will have a slightly negative charge, delta negative. Slightly negative means delta. In chemistry, delta means slightly. Okay, delta negative. And hydrogen is slowly, like chlorine is trying to snatch electron. That means hydrogen is slowly losing that electron. And I told you in chemistry, losing electron means it will give you a positive charge. So a positive charge, and that is the delta positive. So that will give you delta positive charge. Is the concept for delta positive, delta negative okay? Is this like, did you understand this concept? What is delta positive? What is delta negative? What is the key difference between covalent bonding? How will we know which elements will have covalent bonding? And hydrogen during covalent bonding will have a tendency to gain electrons rather than losing electrons, as we were seeing in ionic bonding. Is this part clear?
Yes, ma'am.
Everyone? Okay. So now see, what is polar? You are polar. You know, you have a head and tail. Do you have a head in between your two legs and one above your shoulder? Do you have a structure like this? Like one head is present above your shoulder and one head is present below your legs, between your legs? No, right? If that was the condition, we will say that humans are non-polar. Polar means there are two poles. What are our two poles? We have a head, we have two legs. Okay, understand this more easily. We have a hand. Everyone has a hand, right? I guess no one is handicapped here. Or even if you are handicapped, I guess you have seen a hand. So in a hand, what is present? A thumb is present at one end and a pinky finger is present at the other end. So we can say hand is polar because there are two different poles. One is the thumb, one is the pinky finger. Correct or not? Like, can you relate with me or not? Yes or no? Say.
Yes, ma'am.
Okay. So like that, if the atoms are slightly gaining a negative charge, another is having a positive charge. So these are two different types of charges, that is called polarity. So the bond is polar. Covalent bonds are polar in nature. Is this part clear to everyone? What is polar? Why covalent bond is polar? Okay. Wait. Is this part clear to everyone? What I have told, what I have taught so far?
Yes, ma'am, clear.
Okay, wait. See. For every pair of the electrons shared between two atoms, a single covalent bond is formed. Some atoms can share multiple pairs of electrons, forming multiple covalent bonds. Oxygen, which has 6 valence electrons, needs 2 electrons to complete its valence shell. When two oxygen atoms form the compound oxygen, they share 2 pairs of electrons, forming 2 covalent bonds. What is being said here? Let's see. Wait. See, what is being said? A polar bond is formed when electrons are unequally shared in between the two atoms. Like I said, the snatching concept. Polar covalent bonding occurs because one atom has a stronger affinity for electron than the other. Means that one electron has more electron affinity. I told you the definition of electron affinity in the periodic table in today's class also. Electron affinity means your tendency to pull the, not your tendency, element's tendency to pull the electron towards itself. But you can say, ma'am, if chlorine is more electronegative than hydrogen, it can totally pull away the pull of the electron towards itself. Why it is trying to snatch? Because maybe the electronegativity is not so much higher, like they don't have so much energy to completely pull the electron. Suppose you two siblings are fighting, okay, and you both are trying to have one item. Your brother is you are trying to keep an item, your brother is trying to snatch that item from you. Okay, so obviously, what is the concept? That your brother, he has that of the equal amount, does not have that amount of the equal energy to totally snatch away. Like, yes, he has the power to snatch it away, but not so much energy that he will be totally grabbing that electron from you. Okay, so that is the concept. The electron affinity should be slightly higher, slightly. It is not like it is so much higher that someone is just snatching, it is very much successful to snatch away. In a polar covalent bond, the bonding electrons will spend a greater amount of time around the atom that has the strongest affinity for electrons. Good example of polar covalent bond is the hydrogen-oxygen bond in water. Hydrogen-chlorine, hydrogen-fluorine, hydrogen with anything. Okay. Again, in organic chemistry, I will be starting organic chemistry after I complete this chapter. In the organic chemistry also, we will be seeing concepts, and that is a fun concept. Polarity of the molecule is indicated in terms of dipole moment, which is defined as the product of the distance separating charges of equal magnitude and opposite signs with the magnitude of the charge. So what is the dipole moment? Dipole moment is just, I told you, suppose consider hydrogen and chlorine. Okay, so there is a distance between hydrogen and chlorine. So that distance and multiplied by the charge. Actually, hydrogen and chlorine, they both have same charges, +1, -1. Why minus and plus? And first of all, why 1? Because I told you their covalency is 1. Why 1? Hydrogen in covalent bond will try to gain 1 electron, 1. So number 1 comes from that. So hydrogen is 1. Chlorine will chlorine has 7 electron in its valence shell. I told you yes in yesterday's class also that chlorine, that there is a need for 8 electrons in the valence shell, 8. So chlorine will try to gain 1 electron. So hydrogen is trying to gain 1 electron, chlorine is trying to gain 1 electron. Both are trying to gain 1 electrons. Now chlorine is slightly more powerful than hydrogen. Chlorine will try to pull the electron towards itself, right or wrong? So chlorine is like snatching the electron. One who snatches gains negative charge. So chlorine is -1, hydrogen is +1 because hydrogen is gaining the sympathy. Okay, so chlorine is -1, hydrogen is +1. And what is the dipole? So we can see there is a polarity. One is the plus, another is the minus. Two poles have been created. Now, how can we create, how to measure this polarity, right? Suppose hydrogen chlorine is present, hydrogen fluorine is present. Now, with the same concept, you can tell me, ma'am, hydrogen chlorine, hydrogen fluorine, that is HCl and HF. Both are polar in nature. But ma'am, how can I say which one is more polar? So for that, to measure, to answer your question, which is more polar, we calculate the dipole moment. What is the dipole moment? There is a distance between hydrogen and chlorine multiplied by the charges, which are of opposite sign but has the same magnitude. Is this concept clear to everyone present in the class? Or do I need to say it again? So more. So see, suppose dipole moment, suppose in the exam, how they will give you the question? They will give you a list of the compounds and they will give you their dipole moment values. Or they will give you the distance between them and the charges you already know. Okay. So you will calculate the dipole moment, and more is the dipole moment, more is the polar. More polar is the molecule. Is this part clear? That is how. So is this part clear to everyone?
Yes, ma'am.
Is okay. So after today's class, what you have learned what is covalent bond. You are now able to find what type of elements will show covalent bond. You will now know in covalent bond also there is a polarity. How we will measure this polarity? Through dipole moment. Apart from this, we have also learned that how ionic bond influences the covalent nature. Fajans rule. Okay, so these are the coordinate compounds. I will be starting coordinate compounds in tomorrow's class. So anyone, any doubt, anything you want to ask me? Just remember that if the exam pattern is easy, they will give you the value of dipole moment. And you can just compare the values. You will just arrange them that suppose dipole moments are given as 1, 2, 3, 4. So 4. 4 dipole moment means that molecule has maximum polarity. Maximum polarity means the difference between maximum polarity means that the electronegativity difference is also maximum. Okay, because more electronegative difference, more will be the power to snatch. Just imagine you are a girl and you have three brothers of different age. One of your brother is 5 years, one of your brother is 15 years, one of your brothers are 25 years old. Okay, so when you are fighting with the 5-year-old, okay, so there is a high probability that that you will win, right? So that is what that is not, that should not be considered as the covalent bond, because that 5-year-old brother is not trying so hard to snatch it from you. When you are fighting with the 15-year-old, that boy has power. That boy is trying to snatch away that electron from you. Okay, good. Now, when you're fighting with the 25-year-old who is a fully grown up man, so that will just, okay, that will have more power to snatch it from you. Okay, so this is the covalent. So polarity of the 25-year-old is maximum. That means what? Power of 25-year-old is maximum. And what does this mean? Power of this 25-year-old is maximum. Means that the electron affinity is maximum. Why electron affinity? Tendency of an atom to attract the electron towards itself is called the electron affinity. We are not saying this definition repeatedly. And since you are new, I am repeating this definition every time. So that is the electron affinity. Is this part clear? How you will check the polarity, how you will know which is polar, which is non-polar? Is this part clear? Yes or no?
Yes, ma'am.
Okay. So tomorrow we will be doing with the coordinate compounds, and after finishing this chapter, we will be starting with organic. Okay, that nomenclature, how do we nomenclate, how, and the general organic chemistry. Okay, so ma'am, are you there?
Yeah, yes, sir. Ma'am, thank you,
Okay.
ma'am. Students, join the next session.
Okay, sir.